Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about experimental probability. Okay, so experimental probability is estimating the chance of something happening based on some data we've collected from an experiment. So it's actually doing the game or the test or whatever it is to collect the data to see how many times did that outcome occur. Example 1, use the histogram to find the experimental probabilities. So this is the number of games and the number of points. And this was somebody already did the experiment and tracked how many games they played where they got between 0 and 9 points, between 10 and 19 points, between 20 and 29 points, between 30 and 39 points, and between 40 and 49 points. What is the probability that the team scores 30 or more points? So 30 or more points, I'm going to do 30 to 39 and 40 to 49 out of the total number. Well, from 30 to 39, I have 5. Out of all of them are 16. So there's 16 total games that they played. 5 out of 16 works out to be about 31.25%. What is the probability the team scores less than 20 points? So less than 20 would be 0 to 9 and 10 to 19. And I have 4 plus 2 is 6 out of 16 total games they played, which works out to be 37.5%. Part C, what is the probability the team scores between 20 and 40 points? So between 20 and 40 would be 20 to 29 and 30 to 39, which is 8 out of 16, which is 50%. All right, so this histogram was based off somebody actually playing the game and how many points they got when they played the game. All right, making predictions with probability. Part 1A. If we spin the wheel 240 times, predict the number of times we get a red. So we've already kind of looked at this when we did theoretical probabilities. I have 3 reds out of 9 total outcomes. So I'm going to do 3 out of 9. I can change that to a decimal if I want, or I can work with fractions and put 240 over 1, top times top, bottom times bottom, however you want to work with it. If you plug it in your calculator, you do 3 divided by 9 because fractions just mean division. That's going to give you a decimal, times it by 240, and you get 80. Would you be surprised if you got red 83 times? All right, well, if the theoretical probability is 80, if when I did it, my experimental probability was 83, I wouldn't be that surprised because the theoretical probability, which is 80, is not that much off from the experimental probability of 83. Okay, so that's not that far off, and it could happen when you're actually doing the experiment. You're not always going to get what in theory, you should get. All right, part 2A. If you spin the wheel 135 times, predict the number of times you get a 5. Well, I have 2 5s out of 9 outcomes. So I'm going to take the probability of getting a 5, and I'm going to multiply by 135. So I'm going to do 2 divided by 9, and then I'm going to multiply that by 135. And that gives me 30. Would you be surprised if you got 5 68 times? Okay, well, I would be expecting to get it 30 times. So if I got it 68 times, yes, I would be surprised because 68 is significantly more than 30, the 30 that I was expecting. Over the long run, the theoretical and experimental probabilities should be around the same amount. And 135 times is a lot of times to spin that spinner. So the more times you do it, the closer your experimental probability should be getting to your theoretical probability. So that would be a bit surprising. All right, go Seahawks.